Automatic calculation of medians with ssdwlab5. Let's see how to calculate automatically medians with ssdwlab5 when we have sufficient records for these calculations. We go to the corresponding menu, and we can observe that a relatively complex screen opens. We can see the path of the database, the table from where we'll take the data, the lower limits of each of the markers that can be modified if there are extreme values that cannot be acceptable. In this case specifically, the marker MGO that corresponds the value of free beta HCG in a first trimester screening profile. Moreover, there are days of gestation, and the initial and final values. We value an exponential polynomial curve with two coefficients, and we get the data corresponding to the number of determinations that we have. The median of gestation days, the median calculated for these values, the median of the regression, and the coefficient R2, which gives a good indicator of how the curve fits in the equation. Let's try again with a more complex equation, an exponential with 5 coefficients, 4th degree, which a priori will best suit this graph to the data we have. We see clearly that both the median calculated and the median regression is much better. The coefficient R2 has improved to 0.98. When we look at the graph, surely this would fit better than the previous one in the curve of their chorionic gonadotropin. If we had samples of week 7, we would observe that the value of chorionic gonadotropin increases as well as at week 8. And in the following weeks the value of chorionic gonadotropin descends, so a 4th grade exponential equation could be used as equation of the medians for chorionic gonadotropin. Now, we are going to do the same for the marker MG1 that corresponds, in a first trimester screening profile, to the pregnancy-associated plasma protein A. First, we correct the lower and upper values which could be erroneous that have been introduced in the database. Let's try a polynomial equation without transformation with two coefficients. We see that the days of the week are divided and range from 56 to 98 days. The division factor is 7. Where press compute, and we can observe that this graph gives regression calculations negatives. Evidently this graph would not be correct, because the values cannot be lower than 0. So we should try another equation. Let's try now with a second-degree polynomial equation with 3 coefficients. This is a very useful equation for pregnancy-associated plasma protein A. We can see that both median calculated values and medians regressions are correct. That the coefficient of determination R2 is 0.98, so very high, and this equations don't has values lower than 0 and gives us a very similar curve to pregnancy associated plasma protein curve should be. Therefore we would accept this equation and can be used in the program. And now we will see how to make the calculations for nuchal translucency. Here obviously we are not using days, we use biometrics. So the x-axis we must put the biometry corresponding to the marker MG2. The biometrics MG2 is going to be useful to correlate with the value of nuchal translucency. We define that it is a biometrics and that the initial veil will be 40 or 45, and the final value will be 85 and the division factor is 5. And we use a power of 10 equation, as the published by Nikolides and Kirkel, with 3 coefficients. Here we correct the lower and higher values that can be false, and we press compute. We can note that an interrogation is presented. This is not an error message. It just informs us how the equation of the database is constructed. And we can see in the screen that appears the median calculated, the median corrected by regression of the number of determinations, and as always the coefficient R2 that in this case is 0.99, which is very good. And this is the curve that we would get between levels 40, 45 to 85 mm CRL. and is very similar to that published by Nicolaides with more than 100,000 patients. And that's all about the automatic calculation of medians with ssdwlab5.